Welcome to grade 1. Hopefully, we'll have fun. So, we're going to start out very simple, but we are building very deep ideas, so we have to do it very carefully. So, let's start counting. The way I would like you to count is really to be very careful and slow about the whole thing. So, for example, when you count, there's a very precise meaning of counting. And what do we mean exactly by counting? So, by counting, here I have, in counting, we touch each object exactly once. So, the important idea is that we're going to touch each object exactly once. Those are the important ideas. And I'll explain to you why this is important. But let's first start counting. So, the way I would count is I'd say one apple, and I'd cross out the apple. So this would be one apple, um, one monkey, two monkeys. Then I'd have lollipops. So I have one lollipop, two lollipops, three lollipops. Now please note I'm always counting the denomination. By denomination, I mean I never say one, two, three. I'm always counting objects. So I've said one apple, two monkeys, three lollipops. And there's a reason for it, and we'll go through the reasons. But let's first go through how to count. So then we have four flowers here, right? We have four flowers. And now I would also start changing the order. So maybe I'll say one flower, two flowers, three flowers, and four flowers. The reason for changing the order of counting is that it's important to get this idea across that you can change the order of counting, but so long as you touch each object exactly once, then you're good and your counting is still valid. So, for example, when I'm counting these smiley faces, I'll say one smiley face, two smiley faces, three smiley faces, four smiley faces, five smiley faces. Okay, so I'm changing the order to make sure, and you have to do it in multiple times. You can't do it just once, and I'm sure you know it more than I do, that you'll have to count again and again and again to get this idea across to children. And this is not because children are dumb. Actually, children are very smart, and that's why you have to do it again and again and again. They actually have the right skepticism that they don't believe you. So it's a great, they are really, really smart, and that's why you have to teach them in the right way. Because if you don't teach them in the right way, they will not just be afraid of you and follow your instructions. They're actually genuinely interested in learning. So now what we can do is we can start skipping some objects. So let's say I am going to start counting ice cream. So I say one ice cream, two ice creams, three ice creams, four ice creams, and five ice creams. And I say, oh, I only have five ice creams, right? And hopefully by this time, if the child has absorbed this idea that each object must be touched exactly once, he or she will point out, well, there is a missing ice cream right here. So I didn't touch this one. So and they will point out that you need to cross this ice cream out and get six ice creams. You can play another trick and sort of start counting something twice. So when I'm counting these seven, I guess, watermelons, this is what it seems like to me. So let's start counting. I'll say one watermelon, two watermelons, three watermelons, four watermelons, and now I'm going to add five watermelons, six watermelons, seven watermelons, and eight watermelons. And again, the child has to point out there's something wrong with this, that I've overcounted, I've touched an object twice, and I've violated the rules of counting. Okay? So this is how I would like you to count. And let me try to explain to you why are we counting this way. So here's an explanation for what we are doing. So the first thing is we have to be very clear about what counting is. And the important thing that we try to get across to the child when we are counting, and you have to do it in multiple times, it will not get done once, is that you have to touch each object exactly once. Why is it important is that later on, when they go on to higher mathematics meaning in grades 3, 4, and 5, what they will end up learning is they'll end up learning the commutative and distributive laws. And for these laws, being able to count in different ways is extremely important. So they should be very comfortable with the fact that if you change the order of counting, the number does not change. And this has to be internalized very early on. And this will also become very important in the place value system, the ability to count in different ways. So while it seems very simple, but it's an idea that has to be cemented the first time they encounter counting. That's number one. Number two, why was I emphasizing denominations? Now, so this is the idea of denominations. So why was I emphasizing denominations? By denominations, I meant ice creams or monkeys or lollipops or flowers. Why was I always using their name? Now, the thing is that in real life, we never encounter the number one. As we're walking down the street, you don't encounter the number one or the number two or the number three. You encounter one cycle or two cars or three motorcycles. Okay? So when you're the child's world is a physical world. In fact, our world is a physical world. And we can only count physical objects. And that's what we have in the physical world. But the number one or the number two is an abstraction. It's a very important idea in mathematics. So the number one or the number two or the number three is an abstraction. It does not exist in real life. It only exists in our own heads. So now we can't transfer what is in our heads into a child's head. That's impossible. We share the physical world. So what we can do is we can start pointing out two pencils and two erasers and two sharpeners and two chocolates and two mangoes and two pears and two apples and two pineapples and two shoes and two other things. And then eventually the child on his own or her own will build this idea of the number two in her own head. And that's an abstraction. So you're really trying to get this mental understanding of the number two into their own heads. And that can only come when you are not confusing the number two, which is an abstract idea in our own heads, with the physical two objects or two books or two pencils, which is very different, which is a part of the physical world. So that's why you have to talk about denominations. And the third idea is that the book almost starts out with zero. I'd sort of start out, I'd delay zero. Zero is a very hard number. We don't really appreciate how hard zero is because if you think about it, we never count things that are not there. So when we are sitting in a room, we don't say there are zero lions and zero zebras and zero elephants in the room. That's a weird way of thinking about it. We count objects that are physically there. We'll count there are 4 chairs and 3 tables and 2 desks. That's what we count. We don't count what is not there. So the number zero represents things that are not there. That's a very weird idea. And if you, you can go ahead and look at the history. And if you go to Wikipedia, I'm just trying to show you that the number zero will be the only number that has that is given so much importance that there's an entire Wikipedia article on the number zero. So the number zero is kind of interesting, okay? So what you can really try to do is maybe start, try to represent zero as something not there, but that's not a very obvious idea that the child will accept. Maybe he or she will, but please understand that it took a lot of time for human beings to understand the use of the number zero, and it was actually through the Chinese, the Hindu, the Arab mathematicians that the West learned about the number zero. So it's a very complex history that the number zero has. Treat the number zero with respect. That's my only request to you, that don't just assume that zero is the easiest number. Actually, one is the easiest number to understand. Zero is a pretty hard number to think about. Hopefully, I've made some sense, and we'll continue next time.